Hello, everyone, and welcome to another wonderful day of chemistry. So today we're going to be beginning our chapter on chemical solutions. So throughout this chapter, we're going to be talking about mixtures of different chemical species and looking at the properties of these two mixed components as opposed to the pure components we've done in the past. And this is going to use a lot of our principles of thermodynamics that we talked about last chapter. So during this chapter, we're going to focus on the property of solutions. Now, one of the big things is that this terminology can really apply to any sort of homogeneous mixture of two components, no matter the phase. And in general, what we're going to be doing is we're going to refer to the principal component. So whatever there's the most of, that will be our solvent. And any minority component will be the solute. And it's going to be very important that you're able to distinguish solute, solvent, and solution, because throughout this chapter, we're going to have some properties that are solute dependent, some that are solvent dependent, and some that talk about the solution. So pay very close attention. And I know it's hard because all of them start with sol, which makes it easy to mix up. Now, one of the first important things is whenever we talk about solutes and solvents, we're often thinking about, say, dissolving a solid into a liquid. But it turns out the solvent and solute can pretty much be any sort of phase. You can have a mixture of two gases, at which point this is a solution. It just so happens that it's a gas phase solution. So a great example of this is air. However, we can also end up adding gases to liquids. So this happens classically in carbonated water, but it's actually very important that we do have these gas liquid solutions, because oxygen needs to be in a liquid phase in order for it to move around in your blood or through the ocean. However, one of the other things that's important to note is generally we're going to tend to treat the less mobile phase as going to be the solvent. So a great example is when we're looking at either dissolving a solid in a liquid, where I'm going to have individual solid particles moving around in a relatively stationary solvent. On the converse side, we could end up imagining putting a liquid inside of a solid. So this is a little bit more rare, but you can think about, say, adding water to cloth, where the general solvent phase is going to be the cotton, and the liquid is going to be moving through and around the cotton. So that's a good way, in addition to majority-minority components, to try and look at solvent and solutes. Now, one of the important things is you'll notice that we've got 7 different types of fairly common solutions here. So one of the problems that we're going to note is that each of these solutions needs to be treated slightly differently. We've already talked about some properties of gas mixtures, and you're going to notice that those are going to be very different than when our predominant phase is going to be liquids. So this is something you should keep an eye out for as we move through this chapter. However, we're going to be focusing on 3 major types of solutions. Either we're going to be adding a solid to a liquid. So in this case, adding solid to water to get a saltwater solution. Or you can imagine mixing 2 liquids like ethanol and water, or even oil and water, where you're going to have a mixture of 2 different liquids, with the minority component being treated as aqueous, and as well as gases and water. So classic example is trying to aerate water. So most fishes need some level of oxygen in the water to live. So this would be another sort of solution mixture. And we're going to be focusing on these 3 major types, with a lot of extra focus being put on these gas mixtures as we progress through the chapter. Now, one of the things that I wanted you to keep an eye out for as we move through this chapter is you're going to see a lot of reoccurring themes. And one of the biggest ones that I want you to keep in mind is when we're talking about dissolving any sort of species in water, what we're going to be watching is a battle in between intermolecular forces, which is going to be dominated by enthalpy. So does the salt want to be a solid, or does it want to be dissolved? And entropy, so how much it wants to be free. So in this case, sodium chloride wants to hang out with more ions, but it also wants to be free. And this battle back and forth is going to help determine which phase we're going to be isolated in. So before we end up talking about these general themes, next time we're going to be trying to figure out a good way to quantify the exact amount of solute present in a system. So next time, units of concentration. Until then, take care.